Hey, folks. All right. For this intro, this is like the last part of our unit or our chapter on electric potential. And again, otherwise known as voltage. Electric potential is voltage. All right. So, what we're going to do for the rest of this chapter is we're going to calculate voltages at different locations due to different distributions of charge. So maybe you have a ball of charge, or a line of charge, or a plane of charge. How do you figure out the voltage somewhere near or in those charges? And there are generally two methods in order to figure out a voltage. Okay, so method one is if you know the electric field, if you know the equation for or equations for an electric field. And again, in the previous two chapters, we've talked about how to figure out electric fields. So like we've used Gauss's law, for instance. So if you know the function for an electric field, then, okay, you're going to use delta V is negative the integral of E dot ds. Okay, now we're going to call that method one. Now, some things to note here. This is a delta. Okay, that means change. That means V final minus V naught, and these are voltages again, which means you better know where you're starting from. You better know a voltage at some location. Okay, you got to know a specific voltage. We'll talk about that when we do the examples, like, hey, do I know the voltage at some location? Oftentimes, you're going to use infinity. If you're infinitely far away from an object, the voltage is going to be 0. Okay, so that's usually where we're going to start. Okay, and also this gives you a change in voltage. Also remember, all of our integrals are definite integrals. They have to have a start and an end point. Okay. If the function changes, then you have to do separate integrals. And again, we'll talk about that when we do our examples. Okay, the second method for figuring out electric fields is if your object can be broken down into a series of point charges. Okay, so if you can break your object down into a series of point charges, and especially if you don't know the electric field function in a specific case, then what you're going to do is you're going to say, we know that dV is equal to K times dQ over R. Okay, in other words, let's say you got a line of charge here, okay, and you're trying to find the voltage, let's say right there. Okay, well, this little point on that line makes a certain voltage at that X. Here it is, okay. Well, then what do? Well, then you want to add up all the voltages made by all the points at location X, and you say voltage is K times the integral of dq over r. Okay, so this relies on us figuring out charge as a function of radius. Remember, radius in this case would be like this, and this. Obviously, the radius varies here in that particular example. All right, so that's our method two. So method one, if you know the electric field and it's relatively easy to integrate, you're going to integrate to find a voltage. On the other hand, if you either don't know the electric field or it's easier to think of your object as a bunch of points, then you're going to integrate and you're going to add up point charge potential, KQ over R. And you're just going to add them all up. So on the next several videos, we're going to do examples. And the first question I'll ask is, hey, which method do you want to use to figure out the voltage? You want to use method one or method two? So look for that question as we go. All right, hope that video was helpful and thank you very much.